Dinosaurs once roamed the Earth, but they're no longer around to tell their side of the story. The asteroid impact theory is the leading hypothesis for their extinction, but there are gaps in this theory that scientists are struggling to fill. Let's take a closer look at the evidence and see if we can unravel what really happened to the dinosaurs. Hi, it's me, and this is my channel. When most people think about the extinction of dinosaurs, they picture a large asteroid or comet slamming into the Yucatan Peninsula and bringing an abrupt end to the Cretaceous period and to the dinosaurs' reign over the Earth. But when scientists say that an asteroid killed the dinosaurs, they're simplifying a very complex event that probably unfolded over millions of years. It wasn't an instant or even a decade-long process. It was much more drawn out than that. The asteroid impact theory was first proposed in the 1980s. And since then, scientists have found evidence that supports it, including a layer of rock in Mexico that contains a high concentration of iridium, an element that's rare on Earth but common in space rocks. Scientists also found shocked quartz in the same rock layer, which forms when rocks are intensely heated and rapidly cooled, like from an explosion. These pieces of evidence, along with others, convinced most scientists that an asteroid impact was the cause of the extinction of the dinosaurs. But there's still a lot that scientists don't know, like how long it really took for all life to go extinct after the impact. In 2020, researchers set out to answer this question by studying fossils from the Hell Creek Formation in Montana. This area is famous for being where paleontologists found many dinosaur fossils, including Sioux, one of the most complete Tyrannosaurus rex skeletons ever discovered. The rocks in this area were formed during the late Cretaceous period, and because they're so well preserved, they contain lots of information about what life was like before the asteroid impact and after. In the study, the researchers focused on a group of organisms called foraminifera, which are single-celled marine organisms that build shells out of calcium carbonate. Like many other organisms, foraminifera are still around today, but back then there were many different types of them and they were quite diverse. The researchers collected rock samples from various layers to find out how the asteroid impact affected the environment and how long it took for life to recover. By looking at the fossil record, scientists can learn how quickly life bounced back after major environmental shifts. The researchers analyzed 175 samples from 36 different sites and dated the fossils to determine the age of the rocks. They wanted to find out whether there was a mass extinction at Hell Creek, and if so, when it happened, and how long it lasted. They also wanted to figure out if there was more than one mass extinction event recorded in the rock layers. After analyzing their samples, they found that there was a mass extinction at Hell Creek, but it didn't happen right away. Instead, there was a gradual decline in the diversity of foraminifera that began about 300,000 years before the asteroid impact and lasted 100,000 years after. So the total extinction event lasted for roughly 400,000 years, which is about 10 times longer than scientists previously thought. This isn't the first time that scientists have found evidence that the extinction of dinosaurs was a drawn-out process. A similar study published in 2021 used a different group of organisms called ostracods to analyze how the ecosystem changed after the asteroid impact. Ostracods are small crustaceans that live in freshwater habitats and have a shell like a mini crab. Scientists found that it took more than 300,000 years for the ecosystem to recover after the asteroid impact, which was much longer than expected. It's possible that the reason it took so long for life to rebound was because of a chain reaction of events set in motion by the impact. For example, the impact may have triggered massive earthquakes, tsunamis, volcanic eruptions, and extreme weather, all of which would have had devastating effects on life on land and in the oceans. So while the asteroid impact theory explains a lot, scientists are still trying to piece together the details. There's still a lot that we don't know about what caused the mass extinction and how long it really lasted. As more research is conducted, we may find that the asteroid wasn't the sole cause of the extinction, but instead it was a catalyst that led to a cascade of negative effects. Either way, it's clear that life on Earth took a sharp turn after the impact, and we can learn a lot from understanding what happened next.